Hello everybody, today we are going to learn and we are in the final episode of Exponents and Power. As the final tutorial, I've also made 3 others as is quite evident. So you can go to my channel and check out those videos as well if you haven't done already. Today let's quickly recap what we learned. We learned laws of exponents. We basically learned multiplying powers with same exponents. What it means that if a is raised to the power of c and b is raised to the power of c, which means exponents are equal, I can also write it as a into b raised to the power c. I learned the other thing, dividing powers with the same exponents. A raised to the power c divided by b raised to the power c means that a by b raised to the power of c. But understand that exponents have to be same. Okay. And then I learned what happens when the exponent of any number is 0. A raised to the power 0 is nothing but 1. So why and how? Go back to the video and check it out. Today we will learn decimal number system. So our number system is the decimal number system because if you remember the place values, they're nothing but just multiples and factors of 10, and which is why our number system is the decimal number system. The base of our number system is 10. So we will learn how to express that as exponents. It's very simple. And then we will learn expressing larger numbers in a standard form exponentially. Okay, so 2 things we will learn, and then we will cover the fundamentals of exponents and powers. So let's get into the first one. Let's take a number 4, 5, 7, 9. If you remember place value principles, it was nothing but 4 into 1000 plus 5 into 100 plus 7 into 10 plus 9 into 1. Now if you look at it carefully, now that we know the concept of power and exponentials, can we say that this is 4 into 10 raised to the power 3 plus 5 into 10 raised to the power 2 plus 7 into 10 raised to the power 1 plus 9 into 10 raised to the power 0. We just learned that any number raised to the power 0 is 1. It is the units place, so this basically will be equal to 1. So this is the decimal representation, decimal number system expressed in exponential form. Yeah, and that basically also brings me to the next concept, which is expressing larger numbers. Whenever we express larger numbers, understand that any large number there is a standard form of, there is a standard form. See, numbers can be expressed in multiple ways, but there is a standard form of expressing a large number as an exponent, in form of an exponent. So for example, let's take a number 78901350002. Okay, let's say this is a number. Okay. So what we will do is that we will express it as a, now let's say for any number to be expressed in standard form, what do we do is that we can only have one digit, and we need to have one digit on the right side of decimal, left side of decimal. Rest everything else will be on the right side of the decimal, and then we will multiply it with a number which obviously will be multiple of 10, so that the value of the number is maintained. So let's start with a smaller one. Let's say 78. Can I write 78 as 7.8 into 10? Yeah, remember my lesson on decimals, in which we learned multiplication of decimal numbers with 10, 100, 1000, etc. When I do that, I get, this is 10, and which is why I have adjusted the decimal by 1 point here, right? It is nothing but 78. If there is a number 788, and once again I only have to keep one number on the left of the decimal. So if I say 7.88, I will have to multiply it by 100 to get 788, right? And that is, this method of expressing any number is the standard method, except instead of writing 10, we will write 10 raised to the power 1, because 10 we will now express exponentially. Instead of writing 100, what we will do is that we will put Once again 10 raised to the power 2. So the exponential factor of the number will always be a power of 10, and then I will adjust the decimals accordingly. Yeah, so that's the simple concept. It's not no rocket science. Primarily two concepts: the concept of exponential and the concept of decimal multiplication. That's it. Now let's take this number. If I have to put a decimal point here and I have to make it 7.8901350002, which basically is the ask of the standard form, what will I have to multiply this with so that the original value is the same? Let's count how many digits are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, which means 10 raised to the power 9, and that's my standard form. Simple as that. So like I said initially, if you remember, is that there are many large numbers, and sometimes we need the exponential form to express these large numbers. Now you can say that you still have to write so many decimals, but then you can just, this part, because it is 7.89 something something, we can just approximate a 7.9 into 10 raised to the power 9, and then the number becomes simple, right? And that is why we classically use the exponential or the standard form representation. So these were the only two concepts that I wanted to cover today, and with that I'm very happy to tell you that the fundamentals of exponents and powers, it is over. There are a few more layers on it, and I will cover it a bit later in this journey. But as of now, you have you should have, if you've seen all the 4 parts of the video, yeah, you should be completely thorough with the concept of powers and exponents, and the same concepts are going to see you through for the next few years. Okay, so if there are doubts, you know what to do. Drop me an email and or drop a comment. We'll be happy to answer. See you in the next one.